Commence today's second half of the program. It's our pleasure and honor, actually, to have James Misewich, who's the Associate Laboratory Director at Brookhaven National Labs. James joined Brookhaven National Lab in 2002, and he's currently the Associate Laboratory Director for Energy and Photon Sciences. In this role, he's had the responsibility for a broad portfolio of energy R&D that spans a spectrum from discovery science to deployment technologies. The Energy and Photon Sciences Directorate includes departments in chemistry, condensed matter physics and material science, grid energy efficiency and energy storage, and two DOE national user facilities, the National Synchrotron Light Source 2 and the Center for Functional Nanomaterials. He also has represented Brookhaven National Lab on the New York State Smart Grid Consortium and the New York Battery and Energy Storage Technology Consortium. James is a professor of physics at Stony Brook University, where he teaches and has research collaborations, and where he works with Stony Brook University, Brookhaven National Labs Energy Frontier Research Center on energy storage. The center, he also works in that capacity on the Center for Mesoscale Transport Properties. His current research is focused on strongly correlated electron physics. James, it's a wonder that you have time to join us. We're honored to have you, and we're looking forward to your presentation to give us a glimpse into the future of what we can expect in this exciting world that you're working in.
Well, thank you very much. First of all, let me just do a sound check. Can you hear me?
Yes, we can.
Okay. And hopefully you can see my slides.
Yes, they're coming through.
Okay. Well, good morning, everybody. And, let me start by adding my condolences to the USEA on Barry's loss. Barry was indeed a friend and an ambassador for energy, as you state. So I was asked to say a little bit. This session is about national labs, what's new at the national labs. And I'm going to say a little bit about what we're doing here at Brookhaven. And Brookhaven is the multi-purpose national lab in the northeast part of the US. And so I'm going to start today by talking about some of the New York State energy challenges. We're part of New York State. We're here on Long Island, and I'll just say a few words about that. As already mentioned, I'm from Brookhaven National Lab, but also part of the Stony Brook University, which is part of the SUNY system, the State University of New York system. So let's take a little look about what's happening in New York State, which is kind of an exciting place right now. The state has set some remarkably aggressive clean energy goals, and it's kind of exciting to be in the Northeast, to be in New York State. The state would like to get up to 9,000 megawatts of wind by 2035, 3,000 megawatts of solar by 2030, and 3,000 megawatts of storage by 2030, and 6,000 megawatts of solar by 2025. These are, remarkable clean energy goals. And just to give you the scale, that 9,000 megawatts of wind that the state is aiming at is about half the base load in New York State. So we're talking a very, very substantial amount of renewable energy. Note that energy storage is seen to be a part of these renewables, which tend to be intermittent. So given that, let's just take a little look at what I consider to be the big questions in New York State. There are some significant grid challenges. This is my little map of New York. Here's Long Island. The wind is going to be offshore Long Island. And the way that our team here has thought about this, there are a couple of big questions that need to be addressed. What energy storage technology is going to be able to meet these grid needs? As I mentioned, the state says they want 3,000 megawatts of energy storage, but what is the technology? Is it going to be lithium-ion batteries, essentially Chevy Volt batteries, or are we going to find something that might be a little more earth abundant, more environmentally friendly? We've got safety concerns. Is the fire department going to allow large-scale installation, et cetera. So I think an important major question is, what energy storage technology? How much of it do you need for reliable large-scale wind integration? We don't really know what the intermittency, what the reliability is going to be offshore. We need to measure that wind resource and understand how that might fluctuate over short and long time scales. And then if you determine how much energy storage, where do you put it? Where do you put it so that you'll end up with reliable integration? And so overriding, I should say, everything about the New York State energy vision is operational concerns for the grid. Is it going to remain reliable? When we plug in that offshore wind, we need to make sure that we maintain our reliability. Are we going to be resilient? Being a New Yorker and being on Long Island, I certainly know what it's like to be hit by hurricanes and have your power out for a long time. And then, of course, everybody's aware that we have to make sure that our grid remains secure. So in light of those questions, what are we doing in New York? Well, we're trying to address some of these things. One thing that is a great benefit, located at Stony Brook University, is the new National Offshore Wind Research and Development Consortium. This is a partnership between DOE, it's DOE funded, but New York State has matched the federal investment. And this is providing a substantial amount of money, and there have been a number of calls and work has already started on addressing some of the research challenges for that offshore wind. And the initial work here has been mostly on the platforms, the environmental issues, the platforms themselves, but there is an emergence now of some integration questions associated with the integration of that offshore wind after you get it built. And the first leases have been released, and developers are anxious to build. So having the National Offshore Wind R&D Consortium located on Long Island is very exciting, and a lot of research is now jumpstart in offshore wind because of that. In addition, well, let's look at Brookhaven. This is an airplane view of Brookhaven. As I mentioned, we're on Long Island. We're on the eastern end of Long Island. Our site out here is about 5,000 acres. This is only a picture of the middle portion of the site, kind of our main campus. And I just wanted to point out, we actually have a fair bit of activity in clean energy R&D and assets to bring to the table. So I'll highlight a few here. We have a chemistry department where we're doing work on things like fuel cells, catalysis, molten salts for future nuclear potentially. We have work in biofuels. We have an energy research hub where we're doing a lot of battery work. We have data, and computational science is an important part of all science these days, and so our computer science initiative is an important partner in all of this. And we have, as mentioned in the intro, two national user facilities: the National Synchrotron Light Source 2, which is the brightest US synchrotron. It's only 5 years old, and it's a fantastic X-ray source where we do an awful lot of material science, among other things. And we also have the Center for Functional Nanomaterials, which is one of the 5 national DOE nanoscience centers where we're doing work also on materials. And altogether, we're focusing on a number of issues of interest to the grid. And my next slide, I'll start to dive into a little bit of what is happening at the national lab, at our national lab. And we've been focusing for the last several years on energy storage, and in particular, some of the grid scale aspects. Now, I already mentioned that, there are safety issues, environmental concerns, scaling issues, and customers are, of course, interested in the lifetime, how many cycles you're going to get, the cost. And so we said, we got into this a few years ago because we thought, well, we have these wonderful facilities. How can we exploit those facilities so that we can really do a better job on making the batteries that are needed, not just for transportation, which was a big driver for a long time, but focusing on the grid. And one thing I've learned about batteries is you really want the right battery for the right application. And although lithium ion has some energy density per kilogram, um, uh, uh, attractive qualities, that may not be what you really want to optimize a storage technology for the grid, where it's going to be stationary. You're less concerned about the weight. And so toward that end, we've had investments, thanks to the DOE, broadly, both at the basic side, and it was mentioned in the intro that we have an Energy Frontier Research Center that was renewed not that long ago, called the Center for Mesoscale Transport Properties. Basically, what this is about is trying to understand how you can scale batteries. How do you make batteries larger? And that's what we meant by the mesoscale, getting outside the molecular scale, but understanding the limitations of ionic and electric transport over larger areas, which are important to make larger batteries. So it's all about doing the basic research around scaling. But then there's a wide array of tech, and that's funded by basic energy science, the fundamental part of the Department of Energy, one of the fundamental parts of the Department of Energy. But we also have applied research, and here we're doing things like fast charging, which was mentioned earlier. Now, why do this at Brookhaven? Well, a key part of what we're doing is we can use our synchrotron techniques to do what we call Operando Studies. Now, what this means is we can peek inside real batteries while they're working. And this is, to me, one of the exciting things of building the new synchrotron at Brookhaven. We realized that we would have the capability to do things we couldn't do before. And one of those things we couldn't do before was really get inside real batteries while they're charging and discharging. In this picture are some of our battery scientists, including over on the far right is Esther Takeuchi. She's a National Medal of Technology winner. She invented the battery that goes in implantable cardiac defibrillators. She's literally saved millions of lives. Well, she used to say her best tool for in the laboratory was the hacksaw, because she would chop up a battery after it died and try and figure out what happened inside. Now we could actually do that while the battery is operating. That's what we mean by operando. We can get inside and look at how these things are functioning. And this cartoon, well, this slide illustrates a little cartoon of what we call the bacon reuse battery. And the idea was, can you recycle a battery? One of the issues is that batteries kind of die after a number of cycles. And that's illustrated in the graph here on the right. If you look at that black line, you have a certain capacity that fades as you do cycles, and ultimately the battery dies. Well, can we regenerate that? Can we do something to regenerate? Well, we found that indeed we could. And down here on the bottom left are some X-ray images that are simply showing that, after you made the battery, after cycling, you start to see some structural degradation. But we could regenerate with a simple heat treatment. And so we take the cathode out of the battery, bake it, put it back in, and look at this. We can keep this battery going for a much longer period of time. So this is pretty exciting to us. You could imagine, much like the folks come and replace the air filter in my furnace every couple of months. You could imagine having large batteries where you go in and take out the cathode and take it back, bake it, and put it in, and do some sort of replacement. So it's a way of potentially dramatically improving the cycling of batteries. And fast charging is another area. This was already mentioned by others. This is a place where Brookhaven has been doing a lot of work using our tools to understand what are the barriers that are preventing fast charging. I won't get into details here because of time, But I wanted to end my talk by talking a little bit and introducing you to the other big question: how much do you need and where do you put it? And we've been working with stakeholders in New York State to try to develop a vision for a grid scale innovation laboratory, particularly with the New York Power Authority. They've been wonderful partners. And our vision is to do modeling and so that we can answer questions about how much storage we need, where do we put it, what are the transmission bottlenecks that this large off-scale wind is going to introduce. A lot of this could be done in modeling. And so we designed our center around a number of what we call use cases to address real grid challenges. And here's a short list. Excuse me. Among that list, though, are things like cybersecurity. The next slide is just an example of this center that we've designed, and we've got blueprints for this, where you might imagine having a control room, which is a test control room. That's part of this facility. It would simulate a control room, but then you could have somebody outside that would be doing things like launching cyber attacks. And then you would analyze, see how people respond to that, develop tools to improve that. The whole point is to do this stuff in silica on a computer as a simulation rather than waiting for something to happen on the grid. And so when you think about things like cyber attacks and large scale integration challenges, we'd really like to simulate that on a computer first. And that's the idea behind this. Pretty simple. New York State is, and the Northeast has been a fantastic place for us. I mentioned some of the assets that we already have in place, a lot of great universities. And it's the whole point of this is we would like to de-risk the clean energy future. We want to reduce the risk by getting folks working together. So I know I want to keep on time here. I wanted to end by saying that we're really excited. New York is a leader in clean energy policy. We're lucky to be located in the Northeast, I think. Offshore wind integration is a really significant opportunity. But I just outlined there are some challenges associated with this, with the scale that we're talking about. And, you know, we're Brookhaven National Lab. We're partnering with New York stakeholders, the utilities, the universities, the wonderful folks at NYSERDA, Public Service Commission, to address these challenges in achieving these clean energy goals. And with that, I think I'm out of time, and I'll say thank you.
Well, James, thank you for a fascinating presentation. I found it particularly interesting to the way that the lab and under your leadership is linking basic research and applied research to real-world problems in New York State. Fantastic. I don't think there were any questions, Albert, from the audience yet. So if not, I'm going to take the prerogative of the moderator to ask a couple of questions.
Sure.
Your sort of concluding slides talked about the modeling that you're doing, looking at where to place batteries, where to place transmission. To what extent is it a question of reducing transmission bottlenecks? Or let me rephrase it, how can we use batteries to avoid the expensive, time-consuming, costly process of siting new transmission and place batteries where we're needed so that we don't have to wait for the renewable energy to come online?
Well, that's a great and very important question, and you're absolutely right. One of the great challenges is we are constrained by transmission bottlenecks. And there's a lot of generation upstate, and we have a lot of drain on that power downstate, though, New York City and Long Island. And actually, we're in, if you look at the New York State service, we're in Zone K, the last zone in New York State, and we have a locational capacity requirement of over 100%, which means on a hot summer day, we've got to generate all of our electricity plus the potential bottleneck there. So we really cannot afford to be careless here. We have to figure out either how we're going to build new transmission, or, as you suggest, can you mitigate that with storage? Because our problem in many ways is a peaking problem. The fact that we are peaking for a few hours on a hot summer day, but if we could store and then transmit off peak, that could get greater bandwidth out of our current transmission system without having to build new. And so that peaking is a real, that becomes an issue. And that's why I think we need to do integrated transmission and distribution modeling to really figure out what we need in order to do that kind of balance, and whether it is storage or if new transmission, how much we need and what the real bottlenecks are. But as you could imagine, one of the big bottlenecks is Westchester County. Getting into New York, lower New York State, Manhattan, New York City, and Long Island means going through Westchester, and it's kind of hard to build new transmission there.
I having lived in the New York area, I can sympathize with the problem. James, I really appreciate you taking the time to share with us what's happening at the lab and linking it to, your research to the real world problems that we're seeing in New York and the bright future that you've got in front of us. We hope that you'll consider joining us again at next year's forum, and thank you so much for your excellent presentation.
Thank you very much, and it's really it's an honor to be a part of this. Thanks very much, Will.